Hello, this is Tahmeena Khan, TK. In this video, I will explain you the basic differentiation of four functions which are polynomial, trigonometry, exponential, and logarithmic function. But before starting, let's recall the concept we have learned in maths. So I'll start with that. Now, if you remember in maths, we have done a question where we have to find tangent at different point on the sketch. So we used to plot the graph first, and then at particular point which is asked, we draw a tangent, and then we take 2 points on the tangent and apply the gradient formula, which is y2 minus y1 over x2 minus x1, and then we find the gradient, which gives the gradient at the point x is equals to whatever it is asked. So for example, if question says sketch the graph which we have drawn here, and then it says find the gradient at the point x equals to 4, then we draw the tangent there, and using 2 points we find out the gradient of the tangent, which is the gradient at that point. So now differentiation has made life very simple. So what differentiation is basically, it is a process which helps us to get another function which is represented by dy over dx. So whatever the function is given to you, we will do some process which I will teach you in a while, and that process is represented by dy over dx, which is called first derivative, and then that function helps us to find the gradient. So rather than drawing tangent and take 2 points and then apply gradient formula, if you have another function which is dy over dx of any given function, and then you just substitute the value of x at which you have to find the tangent, you get the gradient directly. So once I have that function which is represented by dy over dx, I can find the gradient at many points very quickly of a given function. So that's why that function is called a gradient function. So let's see how do we apply that process, right? So let's see the procedure here. Okay, so generally, suppose this is my one term, y is equals to axn. First of all, I am explaining in general term, then I will take a particular term with number. So first of all, with algebra. So when you are, sorry, I did not write here a symbol which is a gradient symbol. It is represented by y prime or by dy over dx. Let me write it here first. Okay, so I have written it here, dy over dx or y prime. Now what is the process? Suppose this term is given to you with x power some number, okay? So what you will do, you will multiply the term by the power. So power is coming here, n times a, whatever a is, whatever the number it is, and then you subtract 1 from the power. So for example, if it is 2x power 4, so when you will apply the process, 4 will come here as a multiplier, 4 2s are 8, and 4 minus 1 is 3. So this is the procedure of applying differentiation on polynomial functions, right? Basically it is just one term. I will talk about more terms where we are adding up. So the same procedure will be applied on each and every term of the polynomial. Now we can also write it like this. Sometimes students get confused. When I say y is equals to this, and I'm saying find out dy over dx. So basically what I'm trying to say, okay, differentiate this with respect to, oh, it is with respect to x, sorry. Okay, so I have corrected it. That was mistake in writing. So you will multiply by the power, and then you will subtract the power by 1. This is how you differentiate a term which is in polynomial, algebraic form, sorry. Now let's say your y function is given in 2 terms, right? Ax power m plus bx power n. So when you will apply differentiation, you are differentiating y with respect to x. This is how it is read. Differentiation of y with respect to x, and y is basically this whole thing. So what you will do, power will come here as a multiplier, a times m, and power will be subtracted by 1. Same thing I am doing here. So this is how you differentiate an algebraic terms, and it can be written like this. Rather than y, you can write the whole expression as it is over here. So answer will be same. So let's start with few examples which I have taken from chapter 5, exercise 15.1. Okay, so in this video, because I am only discussing basic differentiation of 4 functions, so I am picking up questions from exercise 15.1, which is polynomial, 18.1 trigonometry, 19.1 exponential, and 19.2 logarithmic functions. So let's start with the first one, which is y is equals to 3x square plus 4x. Now I have written this one here just to show you when there is no power, it means it is 1 and minus 1. So when I will apply differentiation, the process of differentiation is power will come here as a multiplier and power will be subtracted by 1. Similarly, here it is 1. So 4 times 1, it is coming here as a multiplier, and then I will subtract 1 from it. Now why did I write in place of 1, 0? Let's see here. Actually, when a constant is here, you know what is there along? X power 0. And x power 0, when you will apply differentiation, 0 will come here as a multiplier. 1 zeros are 0, right? And the term will turn into 0. So that's why in place of 1, when we are differentiating, we have written 0. So now it will be 3 2s are 6, x power 1 plus 4. Why? Because 1 minus 1 is 0 and x power 0 is 1. Anything to the power 0 is 1. So now I have explained in detail, and now I will take few more polynomial function and we will see the differentiation on it. Now let's see this question. Y is equals to 9x square minus 3 over x square. When you have a variable in the denominator, you have to bring it up in the numerator by the law of indices. Do not start applying the process of differentiation in the denominator. Don't make this mistake, which is often made by students. So first of all, I'll take it up here. You can see by the law of indices. And I did not change here dy over dx. You will write here dy over dx only when you will apply differentiation. Right now I am only changing the form of the function or the expression, right? So now in the next step I am differentiating it. So now you can see 2 is coming here as a multiplier, 2 minus 1 is 1, and then power minus 2 is coming here as a multiplier, and minus 2 minus 1. So very basic rule that power will come with variable with coefficient as a multiplier, and then it is reduced by 1. So now I got 18x plus 6x power minus 3. Now you can leave the answer like this, but usually we leave answer in positive index, so I'll take it down in the denominator, and this is my gradient function. So this is the function and this is the gradient function. If examiner says, okay, find out the gradient at x equals to 1 on this function, so straight away you will substitute 1 here and you will get the gradient, right? Rate of change. And earlier what you used to do in maths, you used to draw this graph, then at x equals to 1 you used to draw tangent line, and then you picked up 2 points. You would pick up 2 points and apply the gradient formula. So this is very easy now. Let's take another example. Okay, so now I'm taking this example. I have taken different examples from exercise 15.1 which look different, but actually the same concept will be applied. Here 2 terms are multiplying with the same base and different powers. It is power 1 and it is power half. Radical sign mean power half. So using indices method law, when base is same, power is different, we add the powers. So you see I have written here y because I am not applying differentiation right now. I'm just simplifying the terms so that I can apply differentiation. So after this, once it is done, now I will apply differentiation. So what I am doing now, Again power is coming here as a multiplier, and then it is reduced by 1. It is coming here as a multiplier and reduced by 1. So now simple algebra, simple simplifications, and then you will get the gradient function, which is dy over dx. Now this is another example. It looks different, but you will write denominator under each term separately because we have to bring everything in numerator. We can apply here another method, which is quotient rule, but where it is possible, apply this simple basic rule, and quotient rule I have explained in my other video. So now I am just writing this denominator under each term separately, right? And after that I am applying law of indices because base is same, power is different. It has power half, it has power 2, so it is going up. So still I have written here y because I did not apply the process of differentiation as yet. I am simply simplifying the polynomial. So now it is all done here. I hope it is all clear. This is going up, so it will become minus power half. So now I will apply differentiation, and what will happen before I show you what I have done here? Can you just revise in your mind because I can't hear you here? Okay, so I think you are thinking correctly that this power will come here as a multiplier and it will reduced by 1. Same thing will happen in all three terms. So let's see. So did you think about the same thing? No problem. Okay, so now simple simplification. Is it okay? And then if you want to leave your answer in this form, no problem. But if you want to change it into radical form, you can. X power half mean root x. X power minus half mean I'll take it down and then it will become root x. And this I will just take because conventionally or usually we don't leave answer in minus power. Though in the book they have left answers just like this. So there is no problem writing it like this or this. It's all right. Okay, so now I will explain the last example of the polynomial differentiation, then we will go to the next function. Okay, so look at this example. Again, single term is multiplying with this. There is no power right now, so it's very simple. Rather than applying product rule, which I have explained in my other video, I will simply multiply this by this and this by this so that I can get two terms. It has power 1. It has power half. So by the law of indices I will add the powers because base is same. So I got my function here. Now once I have gotten this function, I will apply differentiation, and the method is simple. Same, power will come here as a multiplier and power will be reduced by 1. Same is the case here. If you want to see, I have explained here again in case if you have forgotten, because x has no power mean it is 1, so it will be 2 1s are 2, 1 minus 1 0, so it is 2. That's why I have written here 2. So now this is my gradient function. Again, if I want to write in the radical form, I can, and this is the final gradient function of the original function which was here. So now let's start the differentiation process on the trigonometric functions. Now we know three basic trigonometric function: sine, cos and tan. Now the derivative of sine, cos and tan is given here. How do we derive this is not a part of your syllabus, so we will not go into the detail of this. We will straight away just remember this: whenever we are differentiating sine x, it will become cos x. When we will differentiate cos x, it will become minus sine x, and differentiation of tan x is sec square x. Now in this example the x is just 1x, 1x, 1x. That's why we do not write 1. Let's see if it is something else, the angle, because this is your angle. So if it is, for example, sine ax plus b, so what it will be? Differentiation will be Differentiation of sine is cos, we have just seen here on the top. So differentiation of sine will be cos of angle, whatever the angle is given here as it is. You are just focusing on which trigonometric function you are talking about. So differentiation of sine is cos, angle as it is, multiply by the differentiation of the angle. So whatever is here, you will apply differentiation on it. So differentiation of ax is a and b is 0, so I am not writing it. So it will become a cos ax plus b, right? So now let's see another example. If I have y is equals to tan power nx, what is the technique of differentiating it? You have to remember three things. First power, then trig function, and then angle. So I am repeating: power, trig function, and angle. So what I will do, power will come here as a multiplier like this, trigonometric function and angle as it is, and power will be reduced by 1. After that, I will forget the power and I will see what is the function, tan function. So differentiation of tan is sec square x. X is coming because of this angle. And differentiation of tan is sec square. Then multiply by the differentiation of angle, which is x here. So differentiation of x is 1. So that's why I have not written here. So now this will become n sec square x tan n minus 1x. When we will see the example of each one of this with the help of numbers, it will make more sense to you. So let's see the examples. Now these examples I have taken from exercise 18.1 because chapter 18 is about trigonometric function, differentiation of trigonometric function. So the question is y is equals to 4 sin x minus 3. This is one term, this is another term. Differentiation will be applied on each term separately. So 4 is a multiplier as it is, and differentiation of sin x is cos x. We have seen in the few minutes ago, and differentiation of 3 is 0, right? By the way, actually when we are differentiating here 4 sin x, sine become cos and we multiply by the differentiation of angle, like I told you earlier also. So differentiation of x is 1, so that's why we do not mention it here, right? Let's take another example, which is this. This term is simple algebraic term and this is trigonometric. So differentiation of this will be, we will apply trigonometric method. 2 will come here as a multiplier, 4 2s are 8, x, 2 minus 1 is 1. So this term we have dealt like we do it in polynomial. And then trigonometric is what? This is a multiplier, it will remain as it is. Differentiation of tan x is sec square x, multiply by the differentiation of angle, which is 1. So I am not writing it. Giving you 5 seconds to go through it and see what you have done. Then I will go to next example. Okay, so now let's take another example. Now this example is in the form of composite function. We have done it in polynomial. So first of all, we will do the same thing what we used to do in polynomial. 3 will come here as a multiplier. I will show you the solution, but first I am discussing with you because you have done it before. So 3 will come here as a multiplier. This function will remain as it is, and 3 minus 1 is 2. And then multiply by the differentiation of this function, right? We have done this in polynomial. So let's see here. So you see 3 as it is, 3 minus 1, and differentiation of this is 0, minus, and differentiation of cos x is minus sin x. And differentiation of x is 1, so I am not writing here, otherwise I would have multiplied it by that number. So now this will give me this gradient function, right? So this is how you can leave it in this form or this form. It's totally up to, I wanted to write this first, so I have written it here first. Okay, let's see another example. Now radical sign mean power half, right? So it is a sort of composite function bracket power half actually. So when you will differentiate it, power half will come as it is. Power half will come as a multiplier, function as it is, and half minus 1, and multiply by the differentiation of the function inside the bracket. So differentiation of sin x is cos x, and differentiation of cos x is minus sin x, so I have written minus 2 sin x. And after that I'm just rearranging, right? So let's see another example. Now in this example, my angle is not x, my angle is half x, right? So as I was doing earlier, okay, first I was taking care of trig function. If power is 1, we don't worry about power then, and angle is half x. So differentiation of sine is cos, and then differentiation of half x is half. That's why it becomes this. So it is clear that sine is cos, angle as it is, multiply by the differentiation of the angle, so it is half, right? So let's take another example where students usually get confused. Now what is happening here? There is no power, just 1, so we are not worried about power. Otherwise we take care of power first, then trig function, then angle. But anyway, here when we will differentiate, the differentiation of cos is minus sine. So I will write minus sine, angle as it is, multiply by the differentiation of the angle. Now differentiation of 2x is 2, and angle is a number, so differentiation of it is 0. So now it will become this, very simple, right? Let's see another example. First I'll give you 1 minute to think over, and then I will explain it to you. Okay, what is happening here? Okay, in my experience, students usually get confused here. When they have done this, they understood that in the angle one term is with x and other term is just a number, so which will turn into 0. But most of the students cannot figure out what to do here. The only thing you have to do is to split it into 2 parts. So it is exactly like this form. So differentiation of sine is cos, angle as it is, multiply by the differentiation of the angle, which is 3 over 4 minus 0. And then you just have to rearrange it. So your answer will be 6 cos, and angle will be 3x over 4 minus 5 over 4. Right? So let's see the last example now. So in this case, the function is cos square 3x. Now the power of cos is square, right? Now what does it actually mean? Do you know? Cos power 2 3x. It means cos 3x overall bracket 2. Let me write it for you and show it to you. Okay. So actually this means just cos 3x overall power 2. Some students misunderstand it by this, that cos is twice. It is not like this. It is actually like this. So this is the meaning of it. So now we will apply here differentiation, and the process I told you earlier. First we will handle or take care of power, then trig function, and then angle. So 2 will come here as a multiplier, function trig as it is, angle as it is, power subtracted by 1. And then multiply by the differentiation of cos 3x. Forget the power now. So differentiation of cos 3x is minus sine 3x. Now forget everything and just differentiate the angle. So differentiation of 3x is 3. So that's why we are getting it like this. Power, trig, angle. So you will get 3 to the 6 and minus sine and cos 3x and this. So this is how you will get the differentiation of cos square 3x. So remember, it is always index, trig function, and then angle. Okay, so now the last example of the same type. Again, I have taken all these examples from exercise 18.1. Okay, so now this is a function. There are two terms, this term and this term. So when I will differentiate, x will become, yes, come on, 1. And what this will become, let's see. 5 will come here as a multiplier, sine as it is, angle as it is, but 5 minus 1 is 4. Now multiply by the differentiation of sine. Now forget 5, totally forget it. So sine 2x differentiation is cos 2x, and then multiply by the differentiation of angle. So differentiation of 2x is 2. So I got here, after that I just multiply the numbers 5, 3 and 2, which will become 30, and sine 4 cos 2x and sine 2x power 4. Right? So this is how you will get your gradient function. Now this, since video has of length 26 minutes now, so I will explain the differentiation of exponential function and logarithmic function in the next video. Okay, thank you very much for watching it. If you have learned something, you liked it, do press the button like please. It will be very encouraging for me, and subscribe so that you can get my new videos. I'm working in O and A level, both maths videos. Whatever is requested first, I make that one first, right? And definitely the request come from my students first of all. Thank you. Bye bye.